Hello and welcome to the stream, or welcome back for those of you that are still here from doing part two or day two. We are now going to do day 3 of the Advent of Code in Ruby. Trying to write some fun Ruby, right? Design things the way in a way that sparks joy. So without further ado, let's get into it. Thank you, Velor, for subscribing to my YouTube also. Just got an email notification there. Day 3, mull it over. Our computers are having issues, so I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though, says the mildly flustered shopkeeper at the North Pole Toboggan Rental Shop, which I bet if we click on will be a reference to day 2, 2020. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? I get that a lot. The computer appears to be trying to run a program, but its memory, your puzzle input, is corrupted. All of the instructions have been jumbled up. It seems like the goal of the program is just to multiply some numbers. It does that with instructions like mul xy, where x and y are each 1 to 3 digit numbers. For example, mul 4446 multiplies 44 by 46 to get a result of 2024. Similarly, mul 123 4 would multiply 123 by 4. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of a mul instruction. Sequences like mul 4 star, mul 6 9 bang, question mark. Okay, I'm not going to try and read that code out. Do nothing. For example, consider the following section of corrupted memory. Okay. Only the 4 highlighted sections are real mul instructions. Adding up the result of each instruction produces 161. Scan the corrupted memory for uncorrupted mul instructions. What do you get if you add up all the results of the multiplications? All right. Let's take a look at this garbage. Yep, that's fun. I like that it starts with why. Why indeed? Why? How? Who? All right, sure. It looks like it's maybe just one long line. Double check in here. No, it's multiple lines. Oh yeah, I guess that's obvious. I can see where the line breaks are. I mean, am I just going to rubular this one? No matches. And then in here, we're going to want to capture digit on a 3, I think. Like that. Is that right? Hey, I know how to regex. All right. And we'll need captures. So each of these will need to be captured. Yep. Okay, and then it's just a matter of remembering the Ruby API, right? How do we use regexes in Ruby? So this is our beautiful regex that we've defined. I think a fun thing about regexes in Ruby that I learned actually, I think maybe this comes up in the episode of my podcast, Dead Code, where we talked to Kevin Newton about the Prism, Ruby's new parser, is that the Ruby syntax supports, like if you use named capture groups in regular expressions, those get pulled out as local variables, which means the parser needs to know about them, which means that the language's syntax needs to contain the syntax of regular expressions. So there's like a regex engine built into the actual syntax of Ruby, because we need to know that stuff at parse time, which is handy, but kind of crazy. So I'm just gonna go look at Ruby regex, and so we need to pull out all of the matches. And how do we do that? Or do we do this on, or is there a method on string that I use to do that? So gsub is not what we need. Slice. Let's Google Ruby string all regular expression matches. Scan is amazing. That's exactly what we need. Okay, cool. So input.scan for this regular expression is going to return all of them, and what are we doing again? We're summing up all of the multiplications. So we can call sum, and this will give us back a match, and just call this results. I can put on it down here, and this is, I think, oh, these aren't going to be strings. So these are going to be strings. So we need to convert them to, maybe that's the solution. Doesn't seem like the solution. What did I do wrong? Don't see anything obvious. Match. Oh, so these matches are just the two. Well, that explains why that wasn't working. I thought that was going to be a match object rather than just the matched. Rather than just the capture groups. So we can actually just or, you know, because we can do whatever we want. What do we call this? I'm just leaving it as a map to I inject multiplication. In fact, inject I think takes it just as a symbol if you pass it in as a. All right, that looks like a more real result. Not only is it a real looking result, it is the right result. All right, a beautiful solution. Just a regex and some garbage. Love to see it. The best kind of result. Yeah. All right. I'm pretty happy with that. I hope they challenge us a little more on this next one. Day 3, part 1. All right. What do they have in store for us? As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. There are 2 new instructions you'll need to handle. The do instruction enables future mul instructions. The don't instruction disables future mul instructions. Only the most recent do or don't instruction applies. At the beginning of the program, mul instructions are enabled. Interesting. We're getting closer to me wanting to do something really terrible with this. So it gives us an example. This corrupted memory is similar to the example before, but this time the mul and mul 5.5 and mul 11.8 instructions are disabled because there is a don't instruction before them. The other mul instructions function normally, including the one at the end that gets re-enabled by a do. Okay. That's fun. I like this. I like this. I think this is really interesting. Also, I didn't say it before, but I hope everyone appreciates that in this stream today, my audio isn't just in one channel. Anyone who listened to yesterday's stream with only their right headphone on didn't hear a word. Okay, how do we want to do this? This is fun. I like this one. I kind of want to extract all the valid calls, and then, I mean, I'm tempted to do something that involves eval, because that would be funny. But we kind of have to already extract them all, so it's like expand the regex. Yeah, Jiggins, that's probably my first idea. So, or like my first step here. If we go back to Rubular, we can remove the capture groups because we just want to capture the whole thing, I think, now. And then, oh, this is so long. Where's the, okay, so we want, it's that, or it's do, or it's don't. And that, I can't see. Where's a do or a don't in this? Is this working? Does my single quote need escaping or something? I see do. Don't. No, I don't want to search through that. Ha, okay. That is working. All right, cool. All right, so that's, I guess, us, our do's and our don'ts. But it's going to mean that what's happening in here is different. So let's just make sure, let's just check what these are, what A is now, which I think it should be the original match, but let's just double check. Yeah, okay, so those are original matches. Let's do something terrible. My pry habits is to hit Control D to quit the debugger, which is why I keep doing that. All right. let's do a case statement inside of here. So A is either going to be do or don't. Terrible. I don't know what's going on with that. Normally I use Ruby LSP, standard through Ruby LSP to format my code on save, but I don't have that working on this setup right now. Else we know it's a mult, so let's just eval it. And then we just have to implement mul, right? And it needs a flag to turn it on. So we'll say like doing equals true, and then this does doing equals true. This does doing equals false. Oh, we don't want these to these need to return a value though, so that they don't change our result. And then mul is just A times B. Oh, it's if, but it's return 0 unless doing. Do we think this works? This is silly. This is a silly way to do this. Well, it took all the way to day 3 before I started evaling parts of the input, but we're here. There have been historically other advent of code problems where eval came in useful, including one that involved evaluating numeric expressions that had parentheses and stuff in it, and then altering the operator precedence, which there were a bunch of sort of funny solutions around where you just redefined what the plus and the asterisk operators did on your numbers, and then evaluating the original input with the operators switched. But this one's not too bad. This is I could have just evaluated them more similarly to how I did the original by using the original regex or something like that, but I wanted an excuse to write to eval part of the input. So we got it. That's it. Next puzzle comes out tonight. I will probably do it again tomorrow afternoon, probably similarly around 2:30 p.m. or something like that Pacific time. So come by and say hi. But thanks everyone for coming out to the stream.